All right, we're good to go. Okay, getting started now. You guys hear me okay? All right, perfect. So we're going to cover a bit today around some new announcements from NVIDIA and work we've done with some partners, including Microsoft, and some orchestration of agents. So to kind of get quick agenda here, I'll talk about a little bit of the history of the journey we've been on the last few years and where we're at today. I'll talk about some new work from NVIDIA and the Nemotron open model family, and then we'll talk about the ecosystem and how we're trying to help out and contribute more there. So taking a little bit a trip on the journey we've been on. So going back about 3.5, 4 years, I'm hoping many of you remember the ChatGPT moment. We were all very excited to see that these large language models we had known about and been working on for years, now were much, much more capable. And it was an amazing interface. We could ask complex questions and get complex answers back. And so that was an exciting moment. And then fast forward about 1.5 years, DeepSeek published open models that were able to reason. And in terms of open models, this was a breakthrough. Previous to that, the ability to reason wasn't a common thing in the open community. And so that change enabled many, many more open models and abilities to go through complex problems, things like math, encoding, scientific question answer. And then moving forward even further to a few months back, at the beginning of this year, we now were able to see agents, meaning software where we could interact with models in the background, but we're able to get a lot more work done and focus more on the tasks and the outcome and a little bit less on just simple question answer exchanges. And that breakthrough enabled many, many more use cases. And that's where we're going to spend most of our time today. To give a quick overview of how we think about these agents and the work they do. In the kind of upper left, you can see the prompt, which is often a request. It could be work to get done, a job to do. And as that goes into the center, we think about an agent in essentially this kind of a loop where there's some context or background, some knowledge, either what the agent needs to go do, what it has access to, what its skills might be. And then as it starts to proceed, it looks and observes, it looks at what's available, it looks at what it can do, likely can create a plan. It starts to reason through that plan, how it makes progress, what are some of the tasks to be done, and then it goes and starts acting and doing that actual work. And it'll loop through that until it gets the job done. And then in the upper right, you can see things like tools and skills that it will have access to. And so often you can configure these things, an enterprise or a company might provide some of them. There's also security and governance. Just like employees have access to things today, we expect agents to also have access as well. And then in the bottom, of course, there's memory. It can be short-term memory, it can be long-term memory. The idea is allowing it to know what work it's done, what work needs to happen, and also perhaps even broader knowledge of other work other agents are doing as well too. And then on the far left under prompt, you can see orchestration. And so the idea here is that one agent is running through this loop, getting work done. It could even work with other agents and be able to orchestrate workloads with them and across a fleet of agents. And so we think about this idea of these agents being powered by a harness as well as large language models. And so to get even more specific here, we overlaid some icons of where we see large language models running. You can see a lot of it in the center. So they power a lot of the, we'll say, context, observe, reason, act, essentially the work the agent's doing. There's skills, and skills often can run on a CPU. They can also run on a GPU. We have our CUDA software stack there, as well as large language models. There's security and governance that could be access to network protocols or content across a company. At the bottom, there's memory. Memory can take place in many different locations. It can be across the network. It could be local. It could be on CPU, GPU. And there's also some memory inside the LLM as well, too. To take a step now into how we think about these long-running agentic systems and what are some of the key pillars we think are essential. So the first one we think about are systems of models, meaning our view is that in order for enterprises to be the most successful with agents, they will likely need more than one model. And these models might be different languages, different modalities, they might be different sizes, they can run in different locations. And so in this world of a system of models, you can imagine many of these working together. In the center, we think about agents as being specialized, meaning there's a certain skill or set of knowledge that they have. And often inside enterprises today, just like many of us specialize, you can imagine these agents also gaining specialized skills and knowledge. And you can see some fun graphics we have there of our CEO. We call it 𝗦𝗽𝗀𝗀𝗀. But you can see him there having different outfits showing different skill sets. And you can imagine being post-trained or having the knowledge and capabilities and access to certain systems to take tasks and do things. And then on the right, we always think about efficiency. And so we think about pre-training, post-training, and inference, or runtime, or test time thinking. And on the x-axis, we think about compute. And so we're constantly trying to move the curve to the left, meaning we want to improve the intelligence and reduce the amount of compute that it takes so things are able to get done faster. In terms of NVIDIA Nemotron, to give a quick overview, we think of Nemotron as a family of models, meaning checkpoints, as well as data, as well as tools. And inside the Nemotron family, we have some key pillars. And across kind of the center there, reasoning is one of the more common and popular ones. We'll talk a bit about that today. We also have vision capabilities. We have information retrieval, meaning things like embedding and re-ranking. We also have content moderation under safety, and we have work under speech. So think about speech to text and text to speech. All of these are part of the family in terms of being open models with open data sets, as well as the training techniques we use to create them, and software to allow you to customize them. And across the bottom, you can see kind of those families of content that we publish. To be a bit more specific now, in terms of the reasoning side, where we'll spend more time today, and now moving into the agentic world, we have three main sizes of Nemotron models. And we think of these in terms of the GPU type of footprint or infrastructure that is needed to run them, as well as the capabilities of the model and the size and the speed. And so Nano is our smallest, and that focuses on a very small data center GPU. It's a small mixture of experts model, a 30B active 3B. We then have Super that we published in March. The Nano was from December. And in March, when we published Super, think of this as, say, 1 or 2 H100 80 gig type of data center GPUs. And then Ultra, think of this as the largest open model we have. And I'll talk more about it on the next slide. But this will be thinking about, say, 2 B200. So in the data center side, also taking a few GPUs, but being able to provide the best capabilities. And this will be available on Tuesday. And then repeating across the bottom, just emphasizing all of these models, we have open data sets, which includes pre-training data, post-training data, also the RL environments and skills under NemoGym, as well as the research. We continue to publish that as well too. And then the announcement that we made on Sunday, and we want to be able to share more here, is around Nemotron 3 Ultra. And so this is our largest model we've published to date. It's also our most capable model. And Nemotron 3 Ultra, you can think of this as, I'll go into more detail, but essentially frontier reasoning and orchestration capabilities. It's 550 billion and active 55 billion. And across the bottom, we have some of the highlights. So because we focus a bit on the inference and the runtime, you'll see great task completion times, meaning we focus a lot on the output generation, as well as the ability to pre-fill quickly and be able to run through turns quickly on agentic tasks. We also focus a bit on making sure that these translate to lower costs so we can get more work done in less time. And we also spent time thinking about the agentic harnesses in the ecosystem. And we'll have a demo video coming up about that. But we spent time making sure that Nemotron Ultra runs well across the ecosystem of harnesses. And then the last piece to emphasize is everything is open here. So we publish as much as we can, and we do that so it allows people to be able to go look through it, gain confidence in it, and build their business on it. Some of the breakthroughs in Nemotron 3 Ultra that we want to celebrate. The first is in terms of training techniques, we've improved over the years from things like supervised fine-tuning, and then, say, late last year, a lot of it was around reinforcement learning, and now we have multi-teacher on-policy distillation, meaning we're able to use multiple large teacher models. You can think of them as we have various ultra models that are trained on specific tasks. And then we use these teachers and distill their knowledge down into Nemotron 3 Ultra. And so we spend quite a bit of time making sure that our Ultra model learns well from across all the teachers and gains those capabilities and skills. The second is that we have NVFP4 as a precision format that's optimized to run on Blackwell. that allows us to not only reduce the memory footprint, but also accelerate the compute. And one unique thing we've done in Ultra is rather than having separate checkpoints or files for different formats, so previously if we were on Hopper, we would do floating point 8, and if we were on Ampere, we'd do bfloat 16, and with Blackwell, we'd do NVFP4. With Ultra, we're now able to fit one checkpoint, meaning one file, for example, can download from Hugging Face, and that checkpoint runs both in NVFP4 on Blackwell, but also can fall back and run well on Hopper in addition, making it much easier to select the right checkpoint because there's fewer options. Then the third piece I mentioned briefly on the previous slide is we spent quite a bit of time thinking through open harnesses in the ecosystem. And so these are things like open code and Hermes agent, OpenClaw and Pi, making sure that Nemotron runs well across all of them. And then on the far right, there's some architecture and features that we've added in Nemotron 3 Ultra that we also had in Nemotron 3 Super. So there's a hybrid MOE architecture where we made sure that this was compute efficient in the data center, also that it was memory efficient in terms of long context. We have a latent MOE architecture allowing us to be able to reach more experts with less compute. We have multi-token prediction, which allows us that with one inference query, we're able to predict multiple tokens instead of one, which improves the throughput. And then the last piece is we have 1 million context length, meaning that on the input side, we can fit up to 1 million tokens that the model can use to then run through agentic tasks and keep in its memory. To go through some details for Nemotron 3 Ultra, we think of it as it's smaller and smarter, bringing the frontier intelligence. And you can see some references to the right here, Nemotron 3 Ultra running down some tasks on the left. So across the right, we have GLM51, 𝗬𝗍𝗂26, and Qwen35. These are amazing open models. They've been great in the community, and we love seeing the progress. On the NVIDIA side, for Nemotron, we looked at more agentic tasks this time around than we have in the past. And so things like pinch bench, where we look at the productivity of an agent, meaning is it able to call the right tools? Is it able to get the work done? Is it able to do that efficiently? And so you can see some great scores there. We also looked at long horizon planning, and this was a data set or eval from ServiceNow called Enterprise Ops Gym. And this looks at being able to take a complex task. So say something like a password reset that might need to reach many systems, might need to record information, and might need to send responses back, and perhaps things don't work and iterate. And so we also looked at how to make sure that we're running well in that type of environment for an enterprise. Then there's other things on here like coding, which has become a lot more common and popular, and we're excited to see that. Things like instruction following, so make sure that when we give directions to the model, it adheres to them strictly. And then some more agentic tasks around knowledge work. So think of these like, say, more common tasks in common industries like, say, manufacturing and healthcare, and then professional work tasks, things like PhD level work, as well as MBA level work. And then, of course, at the bottom, we have our 1 million context length we're really excited to see. The next slide, we think about both these tasks and accuracy on the y-axis. And so this is from a third party called Artificial Analysis, and they do a great job being able to measure the capabilities of models as well as their throughput or output speed. And so on the y-axis, you have an index, which is a combination of some of the previous tasks. And then you can see the scores from these models across the open ecosystem. And then on the x-axis, you can see the speed, or meaning the output, the speed at which the model is able to generate tokens, which essentially means at speed it's able to think and answer questions. And so you can see in the upper right the idea of being able to have both the frontier accuracy as well as having the throughput and speed. And then for reference, we have NVIDIA Nemotron 3 down there as well. That was our release in March. And so what's exciting here is to see that with that frontier level accuracy, we're able to have 5x faster inference speed. And we expect that we'll likely be able to push this further as well over the next few weeks. The last slide here on Nemotron 3 Ultra, we wanted to think about things slightly differently. And so we have a new chart here that we haven't shared as much in the past. And our first time was our CEO's keynote GTC a few days back. And so in the upper right, or I guess upper left, we're thinking about the cost-efficient frontier, meaning the target of where we'd like to see all models move to. And on the y-axis, it's accuracy, which specifically here means the ability of the model to complete a coding task correctly. And on the x-axis, we have the cost to complete the task, meaning the query goes in, and the model does a lot of work, calls some tools, modifies files. For some of these, might run a compiler, might edit some text files, might grep and search, and then comes back and delivers the correct answer. And at the end of that, we want to measure the amount of tokens and time it takes to then put a price on it. And so we use prices from CoreWeave and Deep Infra and pick the lowest price across these different models. And we essentially priced out how long it took and how much it costs for each task to complete. And so then on the Pareto curve, what you can see here is that at different cost footprints, so say if you had a smaller budget or a larger budget, you can then trade off and select the accuracy or the capabilities of the model. And what we're excited to see here is with Nemotron 3 Ultra, we're moving to the upper left, and we would expect to see over time all of these models start to move more and more to the upper left. And I think going forward, we have a demo that we can show here. And in all the context of everything we shared about Nemotron 3 Ultra, what we wanted to show is not just the model's capabilities, but show it actually running inside an open harness as, so think of it as essentially the brains or a backbone to an agent and being able to do some work and get some tasks done. And so I'll play the demo here and it'll walk through a business scenario and show being able to complete some business outcomes and Nemotron running in the background to make that possible.
Launching a new product. 4 senior leads are working on the launch with a 2-week window.
Are you guys able to hear the audio?
Every senior lead works alongside Hermes agent
No.
on
Okay.
Nemotron 3 Ultra, bringing reasoning, writing, and judgment to every task. When one of them corrects Hermes, the correction is saved as a reusable skill the team can apply.
Maybe I'll pause it real quick and give the intro. So the intro here is that we're taking a look at a small company. They want to do a product launch. And there's 4 different people working in 4 different functions at the company. They have a 2-week window to get all of the content ready for that launch. And then you'll see that inside each of these boxes represent workflows that those people are working on. And so I'll go ahead and continue now.
The Hermes Curator runs on Nemotron 3 Super, processing skills continuously, merging, deduping, rewriting, testing, and promoting only what's ready to share. Anything shared goes through enterprise review and approval. The method is what gets shared, while the launch data stays private. Once approved, the skill joins Hermes' collective wisdom, the company's growing library of proven methods. Months later, the team is moving faster, not from their own work alone, but from each other's. Every method captured by one lifts the rest of the team. Across the company, every colleague's improvement makes everyone's work better. That's the power of Hermes, from News Research on NVIDIA Nemotron 3 Ultra.
Perfect. I'll go ahead and wrap up here and leave some thoughts with you, and then I'll hand it over to my colleague here. So I think what's exciting about the demo, and it might not seem yet because we're just beginning in this journey, but the idea that individual people can create skills, essentially ways for the agents to get their work done. What's exciting is that as these people finish those skills, the agents can now think about these skills and look at ways to generalize them across a company. And then you can imagine that as these skills get generalized, more people are able to pick them up and use them. And you can imagine these skills representing things like experts or subject matter experts across a company. And you can imagine them becoming so great that people are excited to work with these different agents or skills inside a company. You can even think forward to the future of a world where a company builds these great skills or digital employees to help get your work done, that maybe when you look at potential job offers, you might ask what type of agents or skills are available at that company. Because the better the agents and the better the skills, the easier it will be to get your work done. So I think we're just at the beginning of this journey and we're super excited. And Hermes Agent, they have some great work happening there in terms of being able to orchestrate these skills. So with that, I'll hand over to my colleague. Let's see.
Thank you, Joey.
Thanks.
All right, can you hear me well? Awesome. Hi, everyone. My name is 𝗬𝗲𝗀𝗀𝗀𝗀. I'm an AI solutions architect with NVIDIA. And essentially, that means I work with Microsoft every day to help integrate our hardware and our software together and make it better for our customers. So we've talked a lot about the intelligence and the agentic environment and how we can bring our agents to the real world. And I wanted to show you exactly what that looks like. Now, we've worked a lot with Microsoft to think about how these agents can be best used and best implemented into real world scenarios. And a big part of this answer is Microsoft Foundry hosted agents. So I have some of the key features highlighted here. One of the most important is that you're able to bring your own container, your own harness, your own environment, deploy it into Foundry hosted agents. You can give it access to resources just like you would with a regular colleague because it's given an agent identity that's recognized across your environment. You can implement it with a isolated session. So any code that it writes, any documents that it produces can be isolated to just a single session, helping improve security and ensuring that any work done is isolated to a certain user or environment. And lastly, the lifecycle and compliance of hosted agents helps you ensure that you're meeting your auditing requirements, you're meeting your versioning requirements, and you can make sure that whatever agents you deploy in your environment can be utilized to their best ability. So in a real deployment, this is about what it might look like. We have Hermes agent running in Foundry hosted agents. We have our Nemotron Super and our Nemotron Nano models running in Foundry managed compute endpoints. And we are using Intra ID to give this agent access to our external data. So anything from GitHub to Teams to our emails can all be granted through Intra ID to our agents. And this is a massive helper. And I'm going to show you what this looks like in a scenario in just a second. But being able to tell your agent, hey, check my email and take care of this task, look through my Teams at what my boss said yesterday and go ahead and take care of it. Being able to do that through Foundry hosted agents is just such a big improvement in how we can leverage agents and how we can work a lot more efficiently. So without further ado, I'll show exactly what this looks like in a real world scenario. So here I have a Foundry hosted agent deployment running in running Hermes agent that's powered by Nemotron 3 Super. And I just started a new session here in Foundry agent service. So the first thing I'm going to do is just go ahead and ask it about itself. What agent is it running? What model is it running? And you'll see that in just a few seconds, it spins up my new agent session and we get our first response. It tells me it's running Nemotron 3 Super and that it's using the Hermes agent harness. Perfect. All right, so let's see how this agent performs with a real world task. Now my colleague Alex, he sent me an email this morning about a new feature request in 𝗦𝗲𝗀𝗶𝗸𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀😂. One of our internal LLM testing repos. Specifically, we need to add some support for the chat completions endpoint to our benchmarking tool. And this is pretty complex, but I believe in my new agent, so I'm going to go ahead and delegate the task to my agent. Because my hosted Hermes agent is connected to my Outlook and my GitHub through Foundry, it's able to find the relevant email, make the code changes, and open a PR all by itself without my intervention. And a key thing to notice here is that I'm not pasting in the email directly into the context. I'm not including it in my prompt or as a file, anything like that. I'm talking to this agent in the same way that I might talk to a colleague. I'm telling it that my manager sent me an email and I want it to go find the email and to do its thing. So because it has access to Outlook and GitHub, it's going to go ahead and create this PR on our behalf so we can go work on other things. Now, while the agent is working on this PR, let's take a look at exactly what our agent is doing to pull in the context like this. So my hosted Hermes agent has access to several different services. In this workflow in particular, of course, it's using Outlook for email, it's using GitHub, and it's using a coding sandbox for its code testing. And instead of wiring up each service, each authentication flow, each MCP endpoint, and each permission model separately for each individual server and each service, I can simply connect all of these services to the agent through a single Foundry managed toolbox. And I can control all of those capabilities through this single toolbox. And this makes it very easy to grant your agent access to all of sorts of different tools across your company and built into Foundry. So if we look in the Foundry catalog, all of these services are built in. So we have MongoDB, we have access to Teams, we have access to Cosmos DB. All sorts of MCP servers are built into the Foundry toolbox, so we can get up and running very, very quickly. And on top of that, if you want to bring your own MCP tool, your own agent into your hosted agents environment, you can easily do that through this toolbox. And when teams have their own internal systems, they can grant them access to the agent and control exactly the functions that this agent can call through this toolbox as well. So this makes it very, very helpful for administrators to ensure that their agent is not doing anything it's not supposed to. In this example, I've given access for it to read from Teams, but I do not want it sending a message to my manager or sending an email to whoever. So I am only very specifically listing exactly what it can and cannot do. So this makes it very easy to control all of these permissions, all of these tools from a single endpoint. And that matters more and more over time as our workloads become more and more complex, our agents start using more tools. Having this single plane of management is only going to become more and more impactful. So it looks like our hosted Hermes agent has successfully created the PR for 𝗷𝗲𝗻𝗃𝗃. And one of the things I really like here is that Foundry makes it easy to see exactly what happened during this agent's task. We can inspect exactly what tools and which MCP servers the agent used, exactly what steps it took along the way, and how it moved all the way from the original email to the final PR. And this observability is really critical for enterprise-level agents. It gives developers a way to debug and to improve workflows, and it gives organizations a much clearer audit trail that shows how the agent acted on behalf of a user. So all of this is very traceable and very easy to monitor. So let's look at the PR. Everything looks pretty good. All of the code checks passed successfully. The code files look great as well, but there's some things I want to change. First, I want to add Alex, who was the original requester, as a reviewer. If you see, there's no reviewers attached to this PR. And I want to make sure that it includes doc strings in its function, just part of how we work as a company. And more importantly, I want to make sure that anytime the agent works with this repo in the future, it remembers this feedback and it can implement doc strings, it can add Alex as a reviewer anytime it works with this repo. And this is a good example of the sort of self-learning skill mechanism inside a Hermes agent. Instead of treating every interaction as a one-off request and forgetting it later, the agent can turn this feedback into a reusable behavior. And in this case, it's learning that whenever it works with this particular repo, 𝗷𝗲𝗻𝗃𝗃, it can learn that Alex is always supposed to be the reviewer and that doc strings are always supposed to be included. So I can tell this agent to create this skill, and it goes and edits the PR successfully, and it creates the skill for us. And you'll see that if I open the traces here, that it used the skill manage function. So this is an internal function within Hermes that Hermes calls anytime it wants to essentially create a skill, delete a skill, update a skill. Anytime it works with its skills, it uses this skill manage function to control those skills. So let's verify that the agent updated the PR successfully. After our feedback, remember it should have Alex as the reviewer, and it should have the doc strings in the code. So perfect, looks like Alex was added as the reviewer, and it looks like there was a commit added to add doc strings into the PR. Perfect. And notice here I'm using my OAuth pass-through to the agent, so the agent is able to inherit my identity with the GitHub PR. So all of its commits show as coming from myself. Now with Foundry hosted agents, you have the full power to customize these skills that your agent uses. You have the full power to manage them across agents. And these capabilities that are running inside your agent are only going to grow over time. They're only going to be more accustomed to how you work, how your team works, and how your entire organization works. And that's what's great about these long-running agents and how they're going to make such a big impact across all companies. So not only does Foundry enable your agents with tools, but Foundry also allows us to govern these agents through Microsoft Entra ID. So this integration with Entra ID essentially lets you manage an agent's access essentially the same way that you would manage access for a person at your company. I can find this Entra ID from the Foundry UI, and I can grant it access to, for example, a blob storage. So I can go to my storage account, go into IAM, and exactly the same way that I would grant access to Alex or to another colleague, I can look up this agent and I can add it as a reader. So that's exactly what I'm doing this. In this example, I'm giving it read access, and you see I type in that hash that Foundry had for the agent ID, and I add it here, and then I can grant it access exactly like I would with any colleague. So this is great, for example, if you have data that you want the agent to read, or if you have a database that you want this agent to maintain for you, you can control very granularly what this agent can and cannot do through Entra ID's permissions. Now, the key point here is that the agent now has an identity that can be retrieved and managed and governed across your company. Now your agent can be granted access, it can be restricted access, it can be audited, it can be governed using the same kind of controls that enterprises already rely on. And this capability extends far beyond only Azure resources too. As agents become closer collaborators in day-to-day work, we're implementing our agents across the Microsoft 365 ecosystem. And this built-in identity and authentication and access management is really the core of that. And it's only becoming more and more essential, like, as I said earlier, as our agents become more complex and more intelligent. So far we've looked at how Foundry helps control what services and resources your agents can access, but Foundry can also make it easy to integrate your agents into your tools themselves. So now that my agent's configured and I like how it's working, I can publish it and make it available through Microsoft 365. Now, after I fill out some information, I can publish it and make it available to my Microsoft 365 apps, such as Microsoft Teams. So let's open up Teams and look at our new agent and verify that we can talk to this agent number one, and verify that, most importantly, it's remembering the skill, this conversation that we had from an entirely different session. So if I go to Teams, I can pull up the hosted Hermes agent, and I can talk to it directly in the Teams UI. So let's go ahead and ask it if it has the skill for working with the LLM-perf bench repo. Remember, this is the skill that it just created about 5-10 minutes ago, so that it remembers it anytime that we are working with the LLM-perf bench repo. So this means that I can manage these long-running agentic tasks from the same place I already collaborate with my colleagues. I can go into Teams, talk to this agent, it can remember these skills, it can remember this context, and I can use it to essentially help as, my co-pilot, my partner. And as we can see here, the agent is remembering the specific guidance from our previous interaction. So perfect. So this means it's not confined to a single chat interaction. This hosted agent can retain useful skills across interactions, across sessions, across different services. So over time, it becomes more and more aligned to the way that you and your team and your company all collaborate. So to recap, Foundry hosted agents help solve some of the key problems that typically slow down agentic development. With hosted Hermes, we saw this agent take a real task from an email. We saw it go find that email, We saw it leverage the built-in tooling from Foundry. We saw it create its own PR, expose its tools through observability, and learn a very specific skill that it can remember across sessions and across services. So the value here, it's not just that your model can reason or that your model can write code. It's that Foundry gives you this infrastructure and this tooling and observability that you can use to customize your agent and turn that model into a useful enterprise agent. Now, there are so many great features about Foundry-hosted agents and Hermes and Nemotron, so definitely come visit us at the booth, and we'll help you get started. Now, I want to recap some of the key points that, this combination of Nemotron and Foundry Agent Service and Hermes bring to the table for enterprises. So with Nemotron, we're getting the highest token efficiency provided. We're getting frontier intelligence. We're getting open models and training data and open research. And this is post-trained, like Joey said, for agentic use. Now, Hermes is coming in, and it's helping us get the most out of this model. With the Hermes agent wrapper, or Hermes agent plus Nemotron, with Hermes wrapping around Nemotron, we have multi-model orchestration. Our agent is able to continuously learn over time, continuously improve, and become more of an asset to the organization. Now, Foundry comes in here and provides the infrastructure to run this and to support it and to bring it out to our entire company. With the agent identities through Intra ID, this is a big part because we can now treat this agent like we would a regular colleague. We can grant access, revoke access, and integrate it into our different tools, such as Teams, as you saw earlier. The toolbox helps you manage all of the tools and MCP servers that your agent can access in a single control plane. And the secure session management helps you ensure that you don't have any data leaving your session and that every agent, every user gets a fresh session where they have full control over their environment. So if you'd like to learn more, we have this demo running at our booth in the 308 space. So please come by, talk to the experts, and we'd love to talk more. Also check out our NVIDIA models and our Nemo skills. We have tons of resources online for free that you can go use. Not just our models are open source, but all of the research and information about the models as well. So feel free to come find us, ask us questions. We'd be glad to come help. All right, now I have a QR code for you. So please, if you have a chance, fill out the survey and let us know what you think. All right, thank you, everyone.